Good afternoon. Today we are going to work through Paper 2 2015 exam. So remember, make sure you have your calculator ready. I will also remind you just now that each lesson has been split into two sections. Okay, so this first part I'll be working through approximately half of the exam paper, and then you will have 5 or 6 questions similar to try. And then there's a second video, part 2, where I'll work through the last 6 or 7 questions of this paper, and you will have similar questions to try. I get the impression not everyone is going on and doing the second part of the video. Remember, we are monitoring what you are doing, and remember, upload your work into the correctly dated file on class notebook as well, please. Right, let's make a wee start. Right, a house is valued at £240,000. Its value is predicted to rise by 2.8% per year. Calculate its predicted value after 2 years. Okay, this is us working out a predicted, a value in the future. So 240,000. To work out a value in the future, we multiply by. To increase, right, it says it's going to rise. To increase, we multiply by 1 point. Okay, if I wanted to work increase by 28%, I'd write 1.28, but it's 2.8%. So it's 1.02, that's your 2%, 1.028, that's our increase by 2.8%. Per year for 2 years to the power 2. If it was 3 years, it would be to the power 3. Okay, you should be able to try that now in your calculator. Remember, not all calculators work the same, particularly when it comes to trigonometry, but for this question, you should be able to key that in as you see it. When I type that in, I have 253,628.16. Now, before I go on, I will read the question again and check to see if it mentions anything about rounding. Calculate its predicted value after 2 years. Right, I'm happy with that. It's a value, it's in money, that will do. Okay, please be careful. Sometimes it might say to the nearest whole pound. Okay, so that's fine. Remember, 2 numbers after the point. Okay, if it was 1 point, if that came out as 0.165, I would need to round it to make sure we only have 2 digits after the point for money. Okay, that's fine. Right, number 2. Fx is equal to 3x plus 2. So we have this function. It says f of a is equal to 23. Right, there are 2 real versions of this question, okay? And you won't believe how many people get this mixed up. Right, we've got that number 23. We are not subbing in the number 23 in the position of x. That is not what you do. If the question said, find f of 23, and they had the 23 inside the bracket, yes, that's when you replace x by 23, you sub in 23. That is not what this question's asking us to do. Okay, so it says f of a, which is really just this equation with an a in it, fe 3a plus 2, it says it's equals to 23. So this equation is equal to 23. That's where the 23 comes into it. So now we really just have a simple linear equation, and we have to work out what a is. Okay, what do you do with your plus 2? Move it across. What happens on the right hand side? We do 23, take away 2. So what we've got is 3a is equal to 21. Okay, well, if 3a is equal to 21, how do we find a? 21 divided by 3. A is equal to 7. Okay. Number 3, here's a triangle. Calculate the length of AB. AB, I'll call it x, okay? Normally when I have a triangle, to find the value, I generally would call it x. It doesn't really make any difference. Right, triangle, You should be thinking possibly trigonometry, not Pythagoras. Pythagoras, we're looking for a right angle to triangle. So trigonometry, sine rule, cosine rule. Let me bring up our formulas. Sine rule, cosine rule. Here we are here. Remember, this would be from your formula list. Okay, there we are. Let's see. Can we use, now, what I always do is check. Can we use the sine rule? Can we use the sine rule? We can only use the sine rule if we have an angle and a side across from each other where we know both values. Do we have an angle? Yeah, we've got an angle. Do we have the side opposite? No, we don't. We don't know it. Do we have any other angles? No, we don't. Okay, so it's actually impossible to use the sine rule here. So we're not going to use that. It must therefore be the cosine rule. We've got two versions of the cosine rule. The one that says a squared equals and the one that says cos a equals. Here, they're here. There's your two versions there that I'm talking about. Okay. We're working out a length, a side length. The one that says cos A equals, that one there works out an angle. It's this formula here that we're using. Okay, I'm going to wipe that out though because it's a wee bit messy. Right, it's the one that begins with a squared equals. So let's make a go. Okay. Right, a squared equals, I'm just writing down the formula as it appears on the formula list. There we go. Okay, the side that we're working out, a squared, that's our x, okay? And again, you can call it a squared, it doesn't matter what you call it. The wee letters B and C are your two sides. It doesn't matter which one is which. 1.2 squared plus 1.35 squared. Take away. 2bc means 2 times b times c. 2 times 1.2 times 1.35. Cos A, and now we're multiplying. Remember, multiply by cos A. Cos A is the angle 35. Okay? Like what I said earlier, please get your calculator and check you can work this out. Some calculators can deal with this by typing the whole of that in the one, okay? Not all calculators can though, so please be very careful. What I would do is 1.2 squared, 1.44, plus 1.35 squared. 1.35 squared is 1.8225. So I'm actually squaring the numbers separately on their own. Then we're going to write a takeaway sign. Now, please be careful. Right, subtract. You should be able to keep all of that in the one. So I'm going to type in 2 times 1.2 times 1.35 times cos 35. Or check, you might just be able to hit cos 35. You might have to press times. And that gives me 2.654. And you'll notice I'm not just going to write 2.6, okay, because this is not a final answer. We're not rounding or anything. Keep as many digits as you can. Right, let's see. I'm just going to get the final answer here. 1.44 plus the 1.8225. Take away that answer. Gives me... Nope, that's not right. 1.44 plus 1.8225. Take away the 2.65405. Gives me about 0.60845 approximately. Okay, remember this is what a squared or x squared is equal to. Right. If our formula begins with x squared equals, like Pythagoras, there's a final step we have to do. How do you actually find x or a? We take the square root of the number. Take the square root. Gives me about 0.78. Okay, just have a wee last look. Does it look right? Does it make sense? That side x is 0.78. Yeah, the other ones are 1.2. Looks a wee bit smaller than them. It makes sense, okay? It doesn't mention anything about rounding, so I'm going to be happy with that. And I'm going to write the units. These are lengths. The other ones are in kilometres. 0.78 kilometres. Okay. Number 4. Oh, I left a wee spare page. Number 4. Find the magnitude of the vector. Right, the magnitude. Think of a vector as a line. that has a length, it has a distance, okay? When we find the magnitude, it's by finding the length of a line, like Pythagoras. It's a version of Pythagoras. How do you do Pythagoras? You square your numbers, add them, and take the square root. That's exactly what you do here, okay? So, to find the magnitude of vector u, what we do is we take each individual number, individual component of the vector, we square them, we add them all up, and then the last step is we're going to take the square root of it. You don't need to write the square root part there, you can just do the square root at the end, okay? So we're going to square them all, add them up, 6 squared plus the negative 13 squared, and plus the 18 squared. When I square them all, I get 529. Square them and add them up. To get the magnitude, it's the square root of that answer, which is 23. Okay. Number 5. Here are vectors p and q. Find the resultant vector p plus q. Express your answer in component form. Right, I'm going to do this 2 different ways, simply because there was a question recently that asked you to draw the answer, draw the resultant vector. This is looking for the components, okay? Right. First of all, I would say the easiest way is just put it in components just now. Vector p. Okay, vector p, sometimes they put it in bold, sometimes they put a wee line underneath it. Don't you worry about the notation of it. As long as you're getting the right answer, that's all we're looking for. Right, where's the start of vector p? This is the start of vector p here, because the arrow points to the end. That's the end. See the arrow pointing from the start to the finish in the right direction. Right, how do we get from the start to the end? Think of your coordinates. We go across the way first. We're not going in the positive direction, which is that. We're actually going in that direction to get from the start to the end. So we're going 1, 2, 3, 4, 5. 5 along. But it's in the negative direction, so it's negative 5. And then we need to go up 1, 2, 3. We need to go up 3, so it's positive 3. So that's the components of p. We're going to do the same for q. And then we'll add them together because that's what it's looking for. P add q. Where's the start of q? There's a start there. Okay, because the arrow points to the end of q. That's obviously the end down there. So how do we get from the start to the end of vector q? Remember, we're going across the way first. We go along that way. How many? 1, 2, 3, 4. That's in the positive direction. Right, along 4, and then we go down 1, 2, 3, 4, 5, down 5. So those are the components of p and q. What we've been asked to do is add them together. So all I'm going to do is add these numbers together. That's a negative 5. Right, negative 5 plus 4 is the top component, which is negative 1. And on the bottom, 3 add negative 5. 3, when you add negative 5, remember, it's 3 take away 5. 3 take away 5 is negative 2. And that is the answer. Okay? I'm now going to show you another way of doing that. Let me see. I wonder if I could put it on the next note. Right, let me see. Let me rub off a wee bit. Okay, if you want to take that note down, mind pause it. And take the wee note now. I'm going to rub a wee bit off this because I'm going to show you how another way you could have done it. Right. Okay. Here's another way you could have done this question. Now, the reason I'm going to show you this way is because a few years ago they asked you to draw the resultant vector, not just work out the components, they actually asked you to draw it. Right, this is the start of p, this is the end of p. Okay, so p plus q means at the end of p, draw q. So here's the end of p. I'm now going to draw q. Q starts by going along 4 down 5, was it? Yeah, along 4 down 5. So at the end of here, I'm going to go along 4 and down 5. 1, 2, 3, 4, 5. So from here to here. What I've basically done is I've drawn Q. Let me rub out that wee bit. Okay, what I've basically done is I've drawn vector Q attached to the end of vector P. Okay. How to get the answer from that diagram, okay? From that diagram, let's just check. From that diagram, that was the start. This was the finish. How do you get from the start to the finish? You go, let's see if I can do it in a different colour. Yep. You go along 1 in the back direction, which is where the -1 came from, and you go down 2. Okay, so that's an alternative way. However, I think most people would have probably done it this way. Okay. Right, number 6. Right, the Earth is approximately spherical. The radius, calculate the volume. Okay, volume of a sphere. We need to find the volume of a sphere. What do we need to do to get the volume of a sphere? Yes, we need a formula list. Here's a formula list. The volume of a sphere, 4/3 pi r cubed. Oh, we'll do it in red. 4/3 pi r cubed. Okay, remember your volume formulas are all there. Don't memorise them. Okay, the radius is 6400, and it's to be to the power 3. Take your calculator. You should be able to key this in. 4 divided by 3, 4/3. 4 divided by 3 multiplied by pi multiplied by 6400 cubed. Right, okay, we'll get a big number here, 1.0980 blah 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 to the power 12. Okay, that's how my calculator displays this. Okay, you have a look and make sure you can see clearly how yours is displaying the answer. Right, this is not finished. It did actually say give it in scientific notation. Right, that's the scientific notation part. My calculator's dealt with that. Okay, you need to have a wee look at yours. But it also says to 2 significant figures. 2 significant figures. So we're looking for the first 2 digits, which is a 1 with a 0. However, after the 0 is a 9, which is 5 or more. So I'm not going to leave it as 1.0. The 0 is going to bump up to a 1. So it's 1.1 times 10 to the power 12. And that's our answer. Correct to 2 significant figures and in your scientific notation. Okay, now there's a part B of this question. Let's have a wee look. Part B, the approximate value of the moon is 2.2 times 10 to the power 10 cubic kilometres. Calculate how many times Earth's volume is greater than the moon. Right, okay. Right, the moon is 2.2 times 10 to the power 10. Let me go back and find out what Earth was again. This was Earth, 1.1 times 10 to the power 12. Earth is 1.1 times 10 to the power 12. So the question is, how many times the Earth is bigger than the moon? Right, the Earth is bigger than the moon. Look at the numbers, that's power of 10, that's power of 12. So how many times bigger is this one compared to this one? Right, okay. Do you know scientific notations, it does confuse people. Okay, I'm going to make these numbers much, much smaller. Imagine the moon was 2 and the Earth was 10. Okay, what would the answer to this question be then? How many times is the Earth bigger than the moon? How many times is 10 bigger than 2? It's 5 times. Okay, how do you get 5? You do 10 divided by 2. Right, so basically I'm doing the Earth's number divided by the moon's. So it's 1.1 times 10 to the power 12 divided by 2.2 times 10 to the power 10. Again, you should be able to key that into your calculator. Okay. Let's see. Now, when I do that on my calculator, I get about 49.912. Right, approximately 49. Okay. or, I mean, it says on the answers 49.9 or 50. Either or, we're not worried. Okay. I'm going to quickly do number 7, and then after this, please do your other questions. You'll have 5 or 6 questions for you to try, and then do remember come back and do part 2. Right, okay. Algebraic fractions. Oh, we're still on the red pen. We'll just leave it. Makes a wee change. Right, we're dividing by, okay, the method for division then. Okay. Now, remember, add and subtract get a common denominator. Division has its own rule. When you divide, what we actually do is we flip the second fraction upside down and change it to a multiplication. Okay, you get 1 mark for writing that down. That's you showing you know the method. Now, to get the answer, some people multiply straight across the bottom, some people multiply straight across the bottom and then simplify. If you can, however, you can make it easier by, if you see something at the top that can simplify with something at the bottom, t off the top, t off the bottom, like that, for example, then it helps if you simplify a wee bit in advance. I'll take one of the s's off the bottom, because there only is one, but I'll take one of the s's off the top, and that just leaves it with 1s instead of s squared. Okay, right, what am I left with? On the top, that's a 5. 5 times 2s. 5 times 2s at the top. 5 times 2 is 10, so it's 10s. Am I left with anything at the bottom? The s went and the t went, and that is it. That's the answer. 10s. Okay, so remember, go back, try the questions that I've attached that are relevant to these ones, and then you should be going on to video number 2. Right, best of luck. Bye-bye.